Hello! This episode is about Hewlett-Packard 8563E spectrum analyzer. This is a 9 kHz to 26.5 GHz instrument, very capable. I got it recently and I already used it in one of my previous videos about Anritsu signal generator repair. So it works fine mostly, but it has a couple of minor, I would say, problems. One is with Keypad. It does not respond very well. Let's see, this works. You see, it didn't work first time, now it did. 8 works, 9 worked second time, 4 worked only third time, and so on. Pretty much all the buttons are like this, don't respond very well. I need to press hard several times, which is annoying. And the second problem is with focus. I believe it's slightly out of focus. There is an adjustment here, and it does not make a lot of difference. And even best focus is still slightly out of focus, I believe. And also the intensity is not very high. At maximum, I believe it should be much brighter than this. So I think I need to take the instrument apart, clean the keypad contacts, and while I am at that, I might as well look at the display module. I suspect electrolytic capacitors there. So let's take the instrument apart and have a look inside. Here is the back of the unit. There is an optional memory module installed here. We have generic warranty void stickers, probably not genuine, and who cares anyway. There is something missing here. This is marked J7. Probably a cover like this is missing. I'm not sure why. So I need to remove these 4 bolts, and I should be able to slide the cover right off. The cover is off, and this is the top of the unit. The analyzer is just packed, and fortunately there is this service access information here, and it seems like if we put analyzer on the side, we should be able to unfold all the boards. There are hinges here, and I might need that to get to the display module. And I'm hoping that just by removing some screws here on the sides and on that side as well, I should be able to remove the front panel somehow. Let's see how it goes. And this is the bottom of the unit, and there are hinges here as well, so these boards should unfold this way as well. This information is very helpful. The screws here are of different lengths. Some are shorter, some are much longer, and they are pictured here with scale 1:1, so it's exactly this length here, and this is number 4, and there are small marks on PCB next to the holes. Here we are with 3 boards unfolded on the top. This is the inner board. This is the next one, and the next one. And here we have 2 boards on the bottom side. Very cool design. I managed to remove the front panel. Now it should be very easy to remove the keypad. Alright, after removing this metal bracket supporting the buttons on the right side of the display, removing a few screws and disconnecting these two connectors, this keypad can finally be removed. There is some dust here, so I need to carefully remove these rubber buttons and clean the surface. And also look at this dust on the display. Just cleaning it should improve things a little. Here we are, and now just cleaning the board, and these conductive pads should fix the keypad. The keypad is back together, and after cleaning the dust from the screen, it can be seen that there is quite a bit of burning there. So I put the front panel back in place and the bottom boards as well. So now the top boards can be unfolded all the way like so to get better access to the power supply. And I have already removed this cover from it, and we can see that there is quite a bit of dust there. I have to vacuum clean this. And now I removed this display driver board that was sitting here, and there are no electrolytic capacitors here at all. It's quite dirty, needs some cleaning, and who knows, maybe there is some leakage here through the dust, so cleaning it might help, or maybe some adjustments are needed. And there is a chance that there are some bad capacitors in the power supply, and that might affect the display driver. Let's say there might be some wrong voltage somewhere, or a lot of ripple or something like that. Or maybe we just have a degraded tube and nothing we can do about it. I managed to take this power supply board out, and I have already blown some dust from it, so it is a bit cleaner. And what I noticed immediately is these mains filter capacitors, 5 of them. The brand is not visible here, but I believe these are RIFA capacitors known to fail. Perhaps you can see this irregular pattern inside of them through the clear cases, and this is degraded insulation. They can fail any moment catastrophically and burn everything around them badly. So these are time bombs ticking. Dave Jones of the EAV blog has done a video about them not so long ago. I believe a few months ago or something like that. I will dig up a link and put into the description. So I am glad I am doing this servicing of the power supply. At least these capacitors have to be replaced, and of course I will check all the electrolytic capacitors as well. Here they are. The bigger ones are X-class capacitors that can be used across mains. The smaller ones are Y-class capacitors to use from line to ground. And these are for EMI suppression. And these don't look too bad, unlike the ones in the Dave's video. These did not develop visible cracks yet, but I don't want to take a risk here. According to some date codes on the chips, the power supply was produced around 1992, so about 27 years ago. I want to replace these capacitors. Here I desoldered some of the electrolytic capacitors, just to be sure, and some of them looked quite bad in circuit. And these are unusual ones with 3 pins. The third pin is connected here to the case, and there is no brand on them. And I believe this third terminal is not connected. The board is a 4-layer board, apparently. Probably you can see this internal, perhaps ground plane or something. And I used flashlight behind the board like this to have a look, and I believe this third terminal is not connected, like this one, for example. Let's check with LCR meter. Capacitance mode 1 kHz, and let's enable ESR as the second parameter. So these capacitors are 180 microfarads, 40 volts. And this one is 106 microfarads, 0.7 ohms ESR. And this is the best one from these 4. And this is the worst one, 3.6 microfarads and 8 ohms ESR. And for comparison, I found this, not new, but a good one, 180 microfarads, 50 volts. Let's check this one. .164 microfarads and 0.1 ohms ESR. This is how it should be. So these are quite bad. The next one is 10 microfarads, 250 volts. And it is completely dead. Around 1.8 microfarads and 36 ohms ESR. The next is 47 microfarads, 50 volts. And we have about 10 microfarads and 7.4, let's say, ohms ESR. And again, for comparison, here I found a good one. Not this one, this one. 47 microfarads, 50 volts. .39 microfarads and 0.8 ohms ESR. And the next one is this 22 microfarads, 50 volts. And we have around 1.4 microfarads and 39 ohms ESR. And again, I found, for comparison, a good one, also 22 microfarads, 50 volts. .5 microfarads and 2 ohms ESR. And these big ones are not bad at all. This one is 6800 microfarads, 10 volts. And such high-value capacitors usually measure low at 1 kilohertz, but ESR is excellent, about 0.02 ohms. And if we switch to 100 hertz here, we have about 5500 microfarads. And I found, for comparison, again not a new but a good one, Nichicon, and this one shows higher capacitance, 6800 as it should be, but ESR here is 0.0, almost 3, but this is at 100 hertz. Let's go back to 1 kilohertz, and ESR here is 0.02, which is almost the same as this one. So probably this one has a little lower capacitance, but ESR is not bad at all. And these high voltage ones are 470 microfarads, 200 volts. These look quite good. I desoldered one because they are in two pairs in parallel, and we have about 400 microfarads and 0.1 ohms ESR. I don't have a comparison, but these look good. And there are some others here, like this 2700 microfarads, and this 1000 microfarads, and this is 6800 again. I like this one, and this is another 2700. So these measure fine in circuit, and these too, but I am inclined to replace all capacitors here, just in case. I can keep good looking ones for some other projects, just in case, but I really want to give this instrument a new life. And this is a quite expensive spectrum analyzer, perhaps worth around $1,000 or so. And even if I spend $50 on capacitors, that's just fine, no problem at all. So I will replace all capacitors here. Let's use this unusual capacitor as an example of how do I go about finding a replacement. These don't have brand name on them, but I think this is the model 672D. And this third terminal is not connected, so it must be used just for mechanical support, I guess. So let's ignore it. And I measured the lead spacing. It is about 5 millimeters, and they are about 27 millimeters high and about 13 millimeters in diameter. And here they are, 672D V-shaped Sprague capacitors, specifically made for switch mode power supplies, and they promise minimal ESR change and high ripple current capability. And here is this packaging with 3 leads, and if we have a look here, this third lead is not connected to anything. Here it is, no charge potential. And to look at the specifics, I found here a similar model. Here it is, 40 volts, 220 microfarads, and the maximum ESR is at 120 hertz, 0.48 ohms, and at 20 kilohertz, 0.14 ohms. And maximum ripple current is 1.65 amps at high frequency. So I found this datasheet on Mouser, and they are not available here. 10 weeks lead time, minimum order 290 pieces, $3.89 a piece. And similar thing here on DigiKey, nothing in stock, 290 pieces minimum order, and 49 weeks lead time, which essentially means never. So we need to find an equivalent. So let's open a fresh tab here with parametric search. It does not respond yet. Come on. Oh, now it started responding, so let's set capacitance here, 180 microfarads. Let's select 40 volts here. Let's check in stock here, and we have no results. So let's extend the voltage to 63 volts, let's say. And now we have 73 results. Let's apply this. And now let's have a look at the ripple current at high frequency. The highest possible is 143 amps at 100 kilohertz. Let's select this. We have 4 results. Let's select 5 millimeters lead spacing and apply this. We only have 2 results, and this is the same model. The minimum order here is 1000, so we need this one. And this is Panasonic, 180 microfarads, 50 volts, 9000 hours at 105 degrees C. Excellent. This ripple current at high frequency is a bit lower. Impedance, which is ESR, is excellent, even lower than Vishay specified. 8 millimeters diameter, 22 millimeters high. This is a bit smaller than we have now, which is okay. And these are 63 cents a piece, or $4.67 per 10 pieces. So this looks fine, but let's try again. Let's open one more tab and wait until it loads. Here we are. This time let's select a range here from 180 to a bit higher, let's say 220 microfarads, and let's go even higher here from 40 to 75 volts, let's say. Let's check in stock here and apply this. We have 543 results. So now let's select 5 millimeters lead spacing. Now we have 288 results, and here we have ripple current at high frequency. Now we have up to 165 amps. So let's select these, which are higher than we've seen before. Now we have only 11 results. And now let's look at them. Some of them have 4,000 hours, some of them have 8, some have 10. let's look only at these. Eight results remaining, and let's select these 10,000 hours. Why not? We have two results, Rubicon and United Chemicon. 220 microfarads, 50 volts, 10,000 hours, 53 ohms, milliohms ESR, 10 millimeters and 17.5 millimeters high. This is excellent, and almost the same price. So I'll probably buy Rubicons. Why not? $4.47 for 10 pieces. Excellent. And by the way, I also found this Rifa, which is Chemet nowadays, and they are still produced, the same model exactly, PME271M. So the lead spacing is exactly what we want, 20.3 millimeters. I checked, so this is the right size. Plenty of them available for $1.71 a piece, or $13.80 for 10. I'll probably buy 10. New capacitors have arrived, old capacitors have been removed. Now it's time to rebuild this thing. Here is the rebuilt power supply. New filter capacitors here, X class and Y class, and all new electrolytic capacitors. Some are a little smaller than the originals, but that's not a problem. Specifications exceed the ones of the original capacitors. And here is the driver board, thoroughly cleaned. So let's put the instrument back together. The analyzer is back together, and the keypad is working properly now, greatly improved. And the focus is about the same. I would say I set the electronic adjustment to the middle, and then tried adjusting trim pots in the display driver that might affect focus. And I'm not sure there is any improvement. If there is any, it is barely noticeable, and it's fine. It was good enough to begin with. It was a secondary goal and optional. So the primary goal is achieved, the secondary is not quite, but it's fine. And most importantly, the power supply was recapped in the process. And I'm so glad I've done that. Now the long-term reliability of the instrument should be improved greatly. Thank you very much for watching. Bye.